Throughout millennia, our planet has faced multiple ice ages, being entirely enveloped in ice on at least 2 occasions. From the North Pole to the equator, the Earth transforms several times into a giant snowball. In modern times, the landscape has changed drastically. The accelerated melting of ice raises intriguing questions for scientists about the mysteries hidden beneath this vast frozen tundra. The second largest ice sheet on the planet resides here, with an impressive thickness of nearly 3.2 kilometers, covering 80% of Greenland. Speedy glaciers like Jacob Shave move at remarkable speeds of up to 45 meters per day, continuously sculpting the landscape. At the coastlines, these glaciers release icebergs towering over 90 meters, comparable to the Statue of Liberty. However, what makes this island truly unique are the secrets buried beneath its frozen surface. Recently, scientists have begun uncovering them, revealing discoveries that were difficult to imagine. Greenland's ice sheet, stretching over 2.17 million square kilometers, more than 3 times the size of Texas, houses only 56,000 inhabitants, making it the least densely populated place in the world. Due to frigid temperatures, much of the island is uninhabitable. However, in the southwest coast, influenced by the warming Gulf Stream, temperatures are milder, creating a comfortable environment where about a third of the population lives. In central Greenland, temperatures remain constantly below freezing. Snow falling in this area never melts, accumulating over time. Fresh snow deposited on the ice sheet is initially light and fluffy, with a density of about 50–70 kilograms per cubic meter. As new layers add up, the resulting weight compresses the lower layers, gradually increasing their density. At depths exceeding 80 meters, the air bubbles in the snow can't compress any further, causing the snow to solidify into glacial ice. The total ice in Greenland amounts to 2.9 million cubic kilometers, believed to have existed for hundreds of thousands to millions of years. However, Greenland was not always covered in ice. Beneath this frozen cover lies a massive rocky island that was once a lush refuge, where life thrived in valleys, rivers, and numerous lakes. Even today, not all of Greenland is frozen. At the southern tip of the island lies the Chingwa Valley, the only known forested region. With ongoing temperature increases, there's a possibility that this green patch may spur vegetation growth to other parts of Greenland, gradually restoring its green hue. In 1966, us military scientists drilled nearly 1.5 kilometers of ice in northwest Greenland, revealing a past once teeming with vegetation. During the excavation, unique branches, leaves, and plant fossils were discovered, perfectly preserved. Described by scientists as freeze-dried, these fossils unfold almost instantly upon contact with water, appearing as if they were frozen just yesterday. Around 400,000 years ago, parts of Greenland were covered in spruce forests and tundra's cold, flat, treeless regions, but full of hardy, low-lying plants. Today, this region acts as a time capsule, allowing us a glimpse into Greenland's ancient ecosystems. Greenland's thick ice layer acts as a natural insulator. The ground beneath it remains protected from the frigid temperatures and high winds above, while heat from the Earth's interior warms the underlying soil. In certain regions, the ice sheet is firmly anchored to solid ground, offering stability. However, at the edges, where the ice is thinner, the base is unfrozen and the ice rests on wet soil. Should there be abundant water below, the speed of ice flow can increase, potentially accelerating the melting process. Currently, Greenland's ice sheet is melting at a rate exceeding 200 billion tons per year, enough to fill about 91 million Olympic-sized swimming pools, each containing 660,430 liters of water. If all this ice were to melt completely, global sea levels could rise by around 7 meters, causing catastrophic damage for millions of people living in coastal regions around the world. According to a 2019 study, about 680 million individuals live in low-lying coastal areas. By 2050, this number could surpass 1 billion. Presently, Greenland loses more ice than it accumulates. While it may take a considerable amount of time for all the ice to melt, the sheer magnitude of the ice sheet is hard to grasp. Its weight has created such intense pressure that it resulted in a depression in the central region of the island, situated 300 meters below sea level. This same process occurred around 20,000 years ago. A colossal weight caused certain areas of the Earth to sink deeper into the crust. Ice sheets were abundant in various parts of the world at that time. Scandinavia, the Arctic, and vast stretches of the United States and Canada were covered in ice. Nowadays, something fascinating is occurring in these regions. Imagine the surface of our planet as a huge memory foam mattress. When pressed, it compresses, but upon removing the pressure, it slowly returns to its original shape. Similarly, as the ice sheets diminish, the land beneath the ice rises while neighboring areas adjust by sinking. This process is extremely slow, and some areas are still recovering, while others, like the east coast of the United States, will continue to sink for thousands of years. These regions are at a higher risk of sea level rise compared to other parts of the world. Today, Greenland is far from being green. However, scientists have been making observations beneath its ice cover, unveiling secrets the island has been hiding for centuries. In 2013, a new canyon was discovered. This canyon is over 750 kilometers long, 10 kilometers wide, and about 800 meters deep, making it 1.5 times longer than the Grand Canyon in Arizona. Though not yet visible, the canyon is buried under billions of tons of ice. This subglacial gorge likely was once the riverbed of a vast river, formed by frequent flood events that pushed water through the rock about 2 million years ago. It may still be transporting meltwater to the depths of the ice sheet and to the sea. Originally, Greenland housed a massive lake, covering an area as large as the states of Rhode Island and Delaware combined. This lake captured water from at least 18 streams and reached depths of up to 250 meters. Today, the ancient lake is a depression filled with sediments, holding secrets from a time when water, not ice, shaped Greenland's landscape. Decades of research using ice-penetrating radar have revealed a network of mountain ranges, stretching thousands of meters above sea level. Their sharp ridges and deep valleys influence the movement of the massive ice sheet above, adapting to the hidden mountainous terrain. Moreover, there are submerged fjords channels with depths ranging from hundreds to over 1,000 meters, carved by glacial forces. Greenland's glaciers are in constant motion, and where and how they move depend on subglacial mountains, which act as barriers. These mountains guide the flow of meltwater, changing its speed and direction. The fjords serve as corridors that icebergs use to escape into the ocean. The island's icy veil not only hides a mysterious past, but also a vast reservoir of natural resources. Elements found in Greenland's rock, such as neodymium, dysprosium, and europium, are vital for manufacturing modern electronics, renewable energy technologies, and various high-tech applications. Additionally, the subglacial terrain may contain precious metals like gold, silver, and platinum. Greenland also holds a significant amount of fresh water. Trapped in the extensive ice sheets of Antarctica and Greenland, it contains more than 68% of the Earth's freshwater supply. Greenland's unique geological features possess immense potential for geothermal energy development, a sustainable alternative to traditional energy sources. The idea is to harness the heat from the Earth's interior dissipating to the surface, a process known as heat flux. The area along Greenland's west coast exhibits a heat flux 3 times higher than the island's average. Unlike fossil fuels, geothermal energy generation produces minimal greenhouse gas emissions. Perhaps one day, Greenland could be the key to a carbon-free future for humanity. All this makes Greenland a true treasure trove of valuable resources, as well as a place where Mother Nature displays all her creativity. In 2010, scientists discovered peculiar formations beneath Greenland's ice sheet. Initially, they thought they could be ghost mountains, similar to those found in Antarctica. However, as they later discovered, they were mistaken. Known as jelly sculptures, these impressive ice formations are as tall as Manhattan skyscrapers. There are dozens of them in Greenland, made of a peculiar kind of ice that doesn't form in layers but twists or curls. These structures can be up to 120,000 years old. These discoveries highlight Greenland's potential and complexity, not just as an economic resource, but also as a geological and climatic gem offering glimpses into Earth's past and inspiring possibilities for a sustainable future. Using radar images, researchers discovered that jelly sculptures could be found just 1 kilometer below Greenland's white surface. The island, long seen as a layer cake of accumulated snow, holds surprises as one digs deeper. Peeling back layer after layer reveals a point where they cease to be flat. The deep ice appears to have been folded or twisted multiple times. There is complex science behind this phenomenon, but simply put, ice grows from the bottom up as the ice sheet melts and refreezes. It's similar to building a sandcastle. The wet sand you deposit solidifies at the base, adding substance to the lower layers. Similarly, refrozen ice adds to the layers, creating a complex and folded structure beneath the seemingly flat surface, formed hundreds or even thousands of years ago. But deep beneath the mighty ice sheet lies something much older. When Greenland was still a temperate rainforest, the island was struck by an asteroid 1.5 kilometers in diameter. The impact was likely millions of times more powerful than an atomic bomb, causing magnitude 9 earthquakes and massive wildfires. Fortunately, all this happened after the extinction of the dinosaurs and long before the emergence of our earliest human ancestors. These catastrophic events and complex geological structures reveal a Greenland far more dynamic and rich in history than we imagined. Its ice layers are like pages in a book recording significant moments in the planet's history, offering scientists a rare and valuable glimpse into past eras. The asteroid left behind what is now known as the Hiawatha Crater, 31 kilometers wide, currently buried under 900 meters of ice. Discovered in 2018, its location played a significant role. The crater lies under the northwest edge of the ice sheet, where a water stream contains sediments suggesting exposure to rapid and extreme heating. By studying the sand grains, researchers determined that the impact occurred an incredible 58 million years ago. Greenland is one of the Earth's most extraordinary landscapes, holding the secrets of our planet's past. We're only just beginning to peel back the mysteries of this barren terrain, but in the coming years, countless studies will be conducted. Who knows what other secrets might be lying dormant under the vast expanse of ice, waiting to be unveiled? What clues about our planet's future, extraordinary species, or even traces of a long-lost civilization might this near alien land hold? Don't miss the next incredible discoveries. Subscribe now and join a curious and passionate community eager to uncover the secrets of our planet. Your questions and thirst for knowledge are essential. Join us, each click brings us closer to new revelations.